All right, gang, so I'm going to do problem 44 with you, and we're going to set it up. And the first thing that you're going to need to do is go ahead and draw free body diagrams. And since we have two different blocks, I'm going to have my large block, which is 25 kilograms here, and I'm going to draw my little block over here, which is 4 kilograms. Okay, now our large block, we have a weight 1. I'm going to call it 1. And then we have a force normal 1. Those two should cancel out because we're talking about the block moving this direction with an applied force or a push, and that's what we're labeling as P. Now, there is a force here of the small block pushing on the big block, and we're going to call it F of C for contact force. All right, so that's going to be important to realize. So right now we have those going on. Because of that, we can say that the net force over here in the x-plane, okay, will equal m1a, all right? If that's the case, then we can also say that the net force in the x direction on this block is P minus Fc because they're in opposite directions, and that'll equal m1a. All right, so at this point, that's where we are. Now, let's go over to the small block as well. Over here, oops, and I left off one thing, so let me draw one thing, sorry. Let's go back on this block, and there is a friction force or some what we could call static force right here. All right, so that's a frictional force or a static force that we're going to put right here, and let me make that a little neater, sorry. Now, we're going to come over here to our small block, and we have a weight 2, and we have a friction force or a static force that is over here. So that goes up, and we're going to call that a frictional force. All right. Now, it's pushing on the other block, okay, or the big block is pushing on it. So we'll say that there's a contact force here. Because this is the surface that we're talking about and where everything, the movement we're trying to make it not move against the other block up and down, we can also say that this contact force is our normal force. So we can use those interchangeably because what we're going to be able to say is that my net force here in the y direction is roughly 0 because it's not moving. But then we're going to be able to talk about mu because we know that mu is 0.71. We can say mu is our normal force divided by our, nope, it's our frictional force, excuse me, divided by our normal force. That's our formula. Well, since we were able to say that our frictional force was 0 up here, then that would mean that our friction force had to equal W2, which also means that it equals mass times gravity, M2 times gravity. So we can plug that in. Mu equals our M2G over, now we also said that our F of N was equal to our F of C. Right? Well, we're going to want to rearrange this so that we can solve for F of C. Because if we solve for F of C, we know the M2 to be 4 kilograms. We know gravity to be 9.8 meters per second squared. And we know our mu to be 0.71. So we can come up with a contact force between the large block and the small block of 55.2 newtons. Now that'll be important to bring back over to the large block. Now, if we bring that information back over to the large block, we can also say that the net force of the entire system equals mass times acceleration. If that's true, then the net force on the entire system right now would be considered that P, and or how much that P is involved. And then we have 29 kilograms and A. So really A is just a portion of that push and the mass of 29 kilograms. Well, once we have this expression and this expression over here for our force contact, we can come back to this main formula that we set up for the large block. And we can say that P minus our 55.2 newtons equals our mass 1, which is 25 kilograms, times our, what we said acceleration was a portion of our P and the mass related, 29 kilograms. And now you're going to multiply both sides times 29. So you get 29 kilograms P minus 55.2 N for newtons equals 25 kilograms P. So then you're going to distribute, combine like terms, and solve for P. By solving for P, you should come up with an answer of 400. Oops, let me grab my pen again. 400.2 newtons, which due to significant digits should be 400 or 4.0 times 10 to the second newtons. Hope this helps. I'll also be recording some of the free response questions that I gave you. So if you want to go over those as review for your test, this will be good. This was number 44 on chapter 4.